Welcome to the new Transatlantic Cable, a tripartite civil engineering history webinar series. The webinars are coordinated by the History and Heritage Committee of the American Society of Civil Engineers, the National History Committee of the Canadian Society for Civil Engineering, and the Panel for Historical Engineering Works of the Institution of Civil Engineers. In this segment, recorded on March 27th, 2024, Dr. Mike Ircha presents the Chignecto Marine Transport Railway, a Canadian-British consortium.
Hello, everyone. Welcome to the new Transatlantic Cable. This is a series of history and heritage webinars put on by the American Society of Civil Engineers, the Canadian Society for Civil Engineering, and the Institution of Civil Engineers in the United Kingdom. My name is Jim Talion. I'm a civil engineer and a project manager with the city of Fayetteville, North Carolina in the United States. And I'm also chairman of ASCE's History and Heritage Committee. Our agenda today includes some background on this series of webinars, and it includes some information on how to obtain continuing education credit for participating today. And of course, it includes our main event, with hopefully some time for some questions and answers near the end. Our objective of our three learned societies is to develop and maintain high standards of civil engineering practice. And as part of that, we like to memorialize the history and heritage of our profession so we remember how we got to where we are today. In recognition of that, the three societies have jointly established this new Transatlantic Cable series of webinars. The webinar topics are to each involve at least two of the three participating societies. Today's presentation is on the Chignecto Marine Transport Railway, which was a Canadian-British consortium. We're pleased to be able to offer continuing education credits for your participation today. But to obtain a certificate, you will need to complete a survey at the end of this session. And in order to complete the survey, you will need to enter two keywords that are presented during the presentation. These are sort of your passwords to ensure that you were actually here. The first of those two words is now shown on the screen. That's Fleming, F-L-E-M-I-N-G. Please write it down or take a screenshot now, or trust your photographic memory to recall it later, because you won't be seeing it again. Now, moving on to the main order of business. Dr. Mike Ircha has degrees in civil engineering, public administration, urban planning, and ports planning. A former naval officer, Mike was a municipal engineer and planner in Amherst, Nova Scotia, which is on the Chignecto and Isthmus, of which you will be hearing today, and also in Vanier, Ontario, prior to his lengthy academic career at the University of New Brunswick. Mike also served as CSCE's president during the 1996 to 1997 term. So Mike, the floor and the ability to share your screen is yours. Please proceed.
Thank you all for being here this afternoon. This is a talk I've given on several occasions in the past. I think it's really interesting that it nicely links back to Paul Giroux's talk a month ago when he talked about the Eads Bridge crossing of the Mississippi River, because Eads went on to become involved in ship railways. And so we're going to talk about ship railways, and later on you'll see the connection. So one of the questions might be is, why am I doing this? Why have I gotten involved? Well, in the early 70s, as a young engineer planner, I worked in Amherst, as you heard, and in Cumberland County, where the Chignecto Ship Railway was being built. And I heard about this project from many of the local people in the area, and they talked about their grandfathers working on the project and their grandmothers being involved and so forth. And I sort of got interested in it and saying, what is this? Because there wasn't much information. Later on in the late 80s, I was on the National History Committee of the Canadian Society for Civil Engineering. And we like to designate a historic site whenever we have an annual conference. And that year's conference was in Halifax. So I proposed the Chignecto Ship Railway as a National Historic Site. And I had some pushback from some of the members because they said, how can we designate a project that didn't get completed? So off I went and did a considerable amount of research in the archives at the University of New Brunswick, where we have the Ketchum collection. As you'll hear later on, that Ketchum is a Fredericton engineer. And I spent some time there to basically verify that technically the project was sound. Its failure was not a technical issue. The failure was political and financial because of an economic recession. But we'll talk about that as we go on. So let me begin. The Isthmus of Chignecto exists as a 17-mile peninsula, if you wish, or isthmus connecting Nova Scotia to New Brunswick, basically connecting the Gulf of St. Lawrence, the Northumberland Strait, to the Bay of Fundy. And it's a barrier to shipping. I mean, ships that are coming from the Gulf of St. Lawrence or the St. Lawrence River, traveling maybe to Boston, are being forced to sail around Nova Scotia into the North Atlantic, very rough waters, made rougher by the Gulf Stream that's flowing northward along the coast. And so it's dangerous waters. And so for a long, long time, all of the colonists and the governments of Nova Scotia and New Brunswick looked towards having a canal to reduce the voyage length, to save time and insurance costs. But there were challenges in building a canal, which is what everyone talked about in the first instance, because of the tides. The Bay of Fundy has the world's highest tides at the upper end, varying from 40 to 52 feet, whereas at the other end, on the Northumberland Strait, which you can see here in Bay Verte, it's about 8 to 15 feet tides. The waters in the Bay of Fundy are silt-laden, so it's difficult to use those waters in a canal because very soon you'll have to dredge it. There's also problems of finding fresh water to supply a canal. So there were some challenges that the early colonists faced. So there were proposed canals for many years. It began in 1686 when Jacques de Mille was the French intendant from Quebec, and he had visited the site and he said, oh, we could solve this problem. We'll just carve a little canal or a little ditch across there and the river will flow and the tides will wash it out and we'll have a channel. Didn't happen. 1783, Colonel Morse from the Royal Engineers looked at it and said, you know, there's some military reasons we should have a canal across here. In 1808, it was surveyed by the government of New Brunswick's Robert Minette. 1825, followed up by a detailed survey by the Scottish engineer Francis Hall. Hall's study was reviewed by Thomas Telford in Britain the following year, who had a very favorable review to what Hall had done. And in 1843, there was another survey by Crawley from the Royal Engineers. But the idea of canals is a big issue in North America, particularly in Canada, but in the US as well. And we had lots of canals being built in the 19th century. In 1870, the new government of Canada, remember Canada was created by Confederation in 1867. So in 1870, the government undertook a royal commission on canals and recommended that the Bay Verte Canal, which is the Chignecto one, proceed as soon as means could be granted for this purpose. It was supported by Canadian engineer Sir Casimir Gosky and Samuel Kiefer. And at that time, the estimated cost for the canal was about $5.3 million. In 1873, the chief engineer of public works for Canada at the time, John Page, he looked at the situation, reviewed it, and felt that actually it's going to cost more than they anticipated. And so the extreme tidal differences raised the price up to about 7.1 million, and the money at the time. And this higher cost ended up delaying the development of this canal. Another activity that was going on at the same time was that canals were sort of falling out of flavor a bit because railroads were being built. And so we had this golden age of railway development. And in 1853 to 1960, or 1860, get the right century, there was the construction of the St. John to Shediac Railway. That's up along the coast from St. John up to the Gulf of St. Lawrence, allowing cargo to be transshipped down to St. John. So in other words, crossing the isthmus by rail, in the sense that you unloaded cargo in Shediac, shipped it to St. John, and then loaded on ships again to go to the American East Coast. That further reduced the demand for a canal because we found a way to do it. Although high value cargo could go by rail, lower value cargo, potatoes and wheat and ores and things that are bulk commodities just couldn't pay the freight. And so there was still a pressure for a canal. In 1875, a new Liberal government was elected in Canada, and they carried out another royal commission. And at this time, the Bay Bear Canal was not supported. Their argument was that the short distance saved didn't warrant this expenditure. And of course, that leads to further reduced pressure for a canal. So enter Henry Ketchum. Henry Ketchum was born in 1839 in Fredericton, New Brunswick. This is where the University of New Brunswick resides, the main campus. We have other campuses. In 1862, he received the first diploma in Canada in engineering from the University of New Brunswick. The University of New Brunswick's engineering program began in 1854. In 1866, he became an associate member of the Institution of Civil Engineers and a member by 1878. From about 1856 onward, Ketchum gained considerable experience in railway engineering and construction. First, he worked for about 6 years on the St. John to Shediac Railway. He then worked for 5 years on the Brazilian Railway from Sao Paulo to Santos. And then he worked subsequently the Moncton to Amherst and the Fredericton to Edmundston Railway. And he gained considerable respect from Canadian and British investors for his work on the railways. They believed he had a lot to contribute. So as we're talking about canals, at one point Ketchum was thinking maybe we could build a shallow canal and raise boats on pontoons and float them down the canal, because there were problems about getting water and so forth. But he put that aside, and in 1875, he published a series of letters in the St. John's Daily Telegraph proposing a ship railway instead of a canal. He says, why bother partly raising these boats on pontoons? Why not just put them up and put them on rail and carry them across the isthmus? This was far less expensive at his estimate at that time of $2.5 million, which is about 35% of the canal cost. He also argued that it was more feasible because a railway isn't controlled by the tide or the wind. You transport vessels quickly. It's less costly to maintain, and it's quicker and easier to build. So between 1875 and 1877, he designed the Chignecto Ship Railway. And he laid out, he did the survey, he laid out the design, he did all of the design work, building models to demonstrate and so forth. But unfortunately, before he was able to do anything further with his material, the plans and the models were destroyed in the Great St. John Fire of 1877. And this fire basically swept across the downtown area of the city, wiping out all of the buildings. And if you go to St. John today, you'll see the unique design of the replacement buildings are all that period. So in 1877 to 1881, over a 4-year period, Ketchum, because he's working on other projects, he replicated the plans. And he proposed a parallel standard gauge tracks across the isthmus. So he's going to have 2 tracks with 2 locomotives. He designed it with hydraulic lifts to raise the ships on a grid to be hauled on the rails. There were concerns raised that, if you take a ship full of cargo and raise it up, it's going to fall apart. Well, he was able to prove that this wouldn't happen by looking at the graving docks that had been built in London, Malta, and Bombay, where this was happening all the time, and there wasn't a problem, a graving dock being like a dry dock. And in 1881, after he finished his plans, he submitted now a $4.35 million proposal to Sir Charles Tupper, who was Canada's Minister of Railways and Canals. And it was well accepted because it was cheaper, easier, let's do this. And in 1882, the following year, the Canadian Parliament passed legislation providing an annual subsidy over a 25-year period. The Canadian government was going to pay about 1/3 of the cost of the railway, with the rest of it coming from private investors, which was a common process used in Canada at the time. And they also incorporated the Chignecto Marine Transport Railway as a company, and Henry Ketchum was assigned as the managing director. Now, what are we talking about? This is the Bay of Fundy and the Bay Verte, and this is the isthmus, a 17-mile crossing. And this is the proposed canal, a straight line, straight across the isthmus. And as you can see in the profile, it's relatively flat. I think the largest slope was 1 in 500. Earlier, he had proposed a different railway, and he dropped that idea because of the curve. Regardless of how shallow that curve is, it doesn't matter. Boats don't bend well. And so he went with a straight line. You can also see, if you look carefully, you can see the alignment of the proposed canal that went up through the isthmus. These were the earlier canals that had been surveyed. So this is what we are talking about. Ketchum's railway was designed to handle 2,000 deadweight ton ships. These were maximum length of 235 feet, 56 feet wide, and a draft of 15 feet, common ships in those days. And the idea was that we could transfer 12 ships a day. This is with the railway operating, or the locomotives operating 10 miles an hour across the isthmus. So 6 each way. At the Bay of Fundy end, with the high tides, you had a wetlock basin that was designed to handle 6 ships. And the wetlock is basically a gate that you open at high tide, let the water come in, you close it, and the ships that are inside stay there until the next high tide. And you move some ships out, bring some ships in. When you get to the next high tide, you open the gates, they sail out, new ships sail in. So it's 530 feet length, 300 feet wide, and 40 feet deep. And there was the lock gate itself was 60 feet wide. Remember, the ships are 56 feet wide, so there's 2 feet on each side, and 30 feet high. At the Bay Verte end, there was also a smaller wetlock, plus a 4-acre basin for the vessels to sit in, and a 19-foot deep half-mile channel excavated out into the Northumberland Strait. And this shows some of the construction that was going on. This is the wetlock at the Bay of Fundy end of it, and you can see the inserts in the walls for the hydraulic lifts that I'm going to talk about in a moment. And this is the hydraulic pump house to operate the hydraulic system to raise the boats out of the water and to put in the bilge blocks and so forth. So this is what it looked like during construction. The hydraulic lift and cradle system was a steel grid on which the cradle would rest. The cradle was lifted with 20 hydraulic presses. These are 25 inches in diameter with a 40-foot stroke. And the idea was that they would raise a 20-ton ship plus the 1,500-ton cradle up 40 feet in 20 minutes. The cradle itself was made of 3 sections, each 75 feet by 57 feet wide. And so if you put 3 of them together, you're at 225 feet, handling the large ships that you expect. The cradle ran on the twin standard gauge rails that are 18 feet apart. 2 extra strength locomotives were built to pull the cradle across the 17 miles. The rigid steel girders on that were lifting the cradle carried the keel and bilge blocks. As the ship comes in, the cradle comes up to the bottom of the ship so that it sits on the keel blocks. And then as you raise it slightly higher, you slip in the bilge blocks, hydraulically pushing them in and holding the boat steady as it comes out of the water. And the cradles were supported by 64 rail wheels, each 3 feet in diameter. So this is one of the drawings out of the Ketchum collection, which shows the cradle, 57 feet wide, and the wheels on the rails and the twin rail beds 18 feet apart going across the 17 miles. This is a little later on, as the graving dock or the wetlock is now almost complete. The hydraulic lifts will be put into those alcoves to raise the cradle and the grid. In 1888, and we're going to talk about the time frame later on, this is when the Chignecto Ship Railway became the Canadian Marine Transport Railway as a British venture. The whole intention was that money would be raised from British financiers to pay for this railway, the whole process. And so the initial incorporation, we had temporary directors in 1882, but by 1888, it was reconstituted as a British board, a British venture, if you wish, with British chairs and directors. The two British engineers overseeing the project, Sir James Fowler and Sir Benjamin Baker, and the resident chief engineer was named as Henry Ketchum. There were also British companies involved. The chief contractor was John Meags and Son from London. The development of pump houses and hydraulic lifts came from Easton and Anderson of London. The rails and the steel grid were built in Britain and shipped from England. And then there were a number of various Canadian subcontractors that also worked on the project. And essentially, the ship railway's technical aspects, building the ship railway, was never in question. However, as time went on, there were political and public concerns over delays, weather issues, and site issues, the soggy soil, the boggy soil, finances. We were going to talk about the economic depression that occurred. His timing was just off on that, and growing competition from railways. So there were problems, but not the building of the ship railway itself. This is a diagram from the Ketchum collection that shows more or less the process. Here's the ship going into the wetlock. The grid is raised underneath. The bilge blocks are slipped in. It's ready to be moved, to be raised up and then moved on rail, towed by the two trains and moved on rail across the isthmus. The ship railway design itself was technically sound. U.S. engineer Elmer Corthell, and you'll remember, those of you who were here a month ago, will remember Elmer Corthell as an associate of James B. Eads. He worked on the Eads Bridge throughout the process there. Anyways, at one point, Elmer Corthell is also involved in ship railways, and he says, there's no question about the entire success of this work from a commercial and financial point of view. He believed that within 3 years from opening, for business, it will have all it can handle. He further stated at another presentation, there is no doubt in my mind of the entire success of the construction, operation, or economy of this railway. There's nothing novel in the method, only in the combination of methods in this case. Sir Benjamin Baker, the former president of the Institution of Civil Engineers, wrote, my personal inspection satisfies me that no physical difficulties would be encountered in carrying out the works. So it's technically sound, but let's talk about the financial issues and the political problems later on. So first of all, in 1882, first acts of Parliament, I mentioned there were two of them. The first one incorporated the Chignecto Marine Transport Railway as a private railway company, federally chartered in Canada, managed and financed in London to build and operate the railway. So the intention was always financing from Britain with subsidy from Canada. And the initial financing was coming from Baring Brothers of London, which we'll see in a few minutes is significant. The government also granted the railway a federal subsidy of $150,000 per year for 25 years, roughly a third of the construction cost. The following year, a further act of Parliament fixed the capital that they could raise at £400,000 in common shares and £700,000 in debenture shares. So this is where the money is going to come from in London. Ketchum further stated that the company will satisfy the government by the practical demonstration of safe transport over 1 mile of ship railway of a steamer of 1,000 tons burthen, and by raising and lowering said steamer and the hydraulic lifts in full cargo before receiving from the government an installment of a subsidy. In other words, go ahead, take a chance on me. You don't have to pay anything until I prove this works. Later on, this condition made it impossible for the railway to receive government funds when financial support was critical for the continuation of the project. With these acts in hand, Ketchum went to London to raise funds, and he found the financiers didn't like that particular subsidy, and so they sent him back. And so in 1886, another act was passed by Parliament to amend the subsidy to $170,000 a year for 20 years at 7%. And to do this, the government said, we want to receive 50% of the surplus of profit above 7% to repay the subsidy. And by the way, the government has to approve the survey, the plans and specifications. So in 1886, the Chignecto Ship Railway Company in Britain, the new board of directors, contracted with the government to build the ship railway. Work began on the two dock sites, the Tidnish end and Bay Vert and the Bay of Fundy end in Amherst. Work began on the two dock sites. By 1888, the government had approved the plans and specifications for the actual construction, but the July 1889 date that had been in the initial contract was no longer feasible. They expected about a 3-year construction period. So a new act was passed to extend the completion date to July 1891, with real work beginning on the actual project in October of 1888. Problem then, because then we'll talk about this later on, there was really bad weather that month, 3 times the normal rainfall. So there were lots of delays getting started. In 1889, the initial prospectus was issued in London to raise capital. And there was no problem raising £400,000. But at this point, the Barings brothers had gotten overexposed in their defaulted loans in Argentina, leading to what is known as the Baring crisis of 1890. And because of this, the country's financiers were becoming very jittery. So they could only get about £250,000 in the mortgage debentures that we're trying to do. 1890, the global depression continues, and it's now spreading not only in Britain, but into the US as well. And the railway was unable to raise any further bonds. This is just a picture of the prospectus that was put out, and you'll see that it's share capital, 300,000 plus 100,000 in shares, and then the mortgage debenture here at 700,000. Also lists the directors of the company, and you can see they're all British directors. The financial difficulties continued because John Meigs and Sons also were partnered with Barings in building projects in Argentina. And when the Argentinian government defaulted on their debt payments, they too went bankrupt. And the end result was the ship railway project was suspended in 1891, with about 2/3 of it completed. £3.5 million had been expended at that point. The hydraulic machinery was built and delivered. Pump houses and wet locks were finished. The rails, sleepers, and ballast had all been delivered. The line had been graded for 16 miles with 12 miles of track laid down. The locomotives and cradles were ready for delivery, and the moles at the Bay Vert end were completed. And quoting a maritime historian who reviewed the process, he says, still few regarded the stoppage as more than temporary, since less than $1.5 million was needed to complete the line. Ketchum remained confident that the work would be completed by 1892. So this just shows where we are in 1891, the bed being graded and waiting for the track to be laid on it. So now we run into political problems. In 1891, we need to extend the completion date. I mean, obviously things have been suspended. We need to get a better completion date. And so the government said, okay, we'll give you an extension, but you've got to have your works underway and we need to have the capital secured by 1894. Oh, 1893, the depression continues and there's no money being raised. So everything is suspended. CMTR requested a completion extension to 1895 in 1893 and financial guarantees for the remaining bonds. If the government guaranteed the 7% on the bonds, then we could sell them and get money to finish the project. But the government says, well, you made a promise that no subsidy would be paid until the ship railway was operational. This became a problem. The ship railway then sought support from Charles Tupper, who was then the High Commissioner to England, Canada's High Commissioner. And he concluded in the discussion from them that I do not think it is possible to induce the government of Canada to change the original basis on which the subsidy was voted. By 1894, though, the CMTR had managed to secure a new contractor, Pearson and Son of London, and raise the remaining funds to complete the project. But the CMTR needed a 2-year extension to get the project underway. And the government, well, there were other priorities and they didn't get around to it. By 1895, the public perception and maybe even the political, well, I know the political perception was that the ship railway project is becoming questionable. You know, there's all these delays, there's weather problems, financial issues, the market's changing, the railway competition is growing, and there's waning political support. It's not a national project anymore. It's not even necessarily a regional project. The members of parliament from Halifax and parts of Nova Scotia weren't supporting this anymore. I mean, the Halifax merchants weren't happy that ships weren't going to stop anymore. They were going to go through on the ship railway. So there were all sorts of political issues floating around. However, in 1896, the government of the day gave an order in council to approve the 2-year extension. So government says, okay, let's go. However, there was a little snag in the works that the CMTR charter had lapsed because it hadn't finished the work and it was no longer, whatever the time frame of the charter had lapsed. And so all we need is a private member's bill in the House to approve the extension of the charter. The subsidy is going to be extended and everything's great. And there's a vote. And in the vote for the renewal of the charter, it fails 55 to 54. And the government says, well, that's it. The project's finished. We can't extend it. The charter's not there. And so in the end, it was Parliament, not the government itself, that scuttled the Chignecto ship railway. So here we have a project that's almost finished. We just need some money and some government support, and it falls apart. And to make it worse, the Liberals won the federal election in 1896. And the ship railway was considered to be a questionable conservative project. This is where you're getting not solid bipartisan support for this project. In 1897, the CMTR approached the Liberal Prime Minister Wilfrid Laurier to provide an extension to the contract and the subsidy and to the lapse of the charter. And he said no. He says, because the present Canadian government did not think the ship railway would be commercially successful. And in reality, that reflected contemporary realities of the day. Coastal shipping was declining, at least on that coast, as freight was increasingly being carried by rail. You know, rail lines were being built down from Montreal into the US. You could connect from Quebec to Montreal down into the US. And so do we need to ship things by sea all the way around through the Gulf of St. Lawrence? So trade was changing, and the government's decisions tended to reflect some of that reality. So just to finish up on the Chignecto Marine Transport Railway, in 1896, realizing they'd come to the end of the road, they changed tactics. They lobbied for compensation continuously year by year until 2014. They sought to sell assets to the government. In 1914, World War I occurred and the government really wasn't interested in listening to them anymore, and that was the end of their quest. Now, I don't have information as to all of the assets that were sold. I expect things like the locomotives and the cradle and some of the mobile assets were sold to other companies. In 1903, the government did purchase some of the assets from the ship railway for $100,000. A long way from the amount that were invested. The rails themselves went to the intercolonial railway that was being built in Eastern Canada. The bricks from the pump houses went to build the Fort Beausejour Museum, a close by facility. The heavy armor rocks in the project were transported to Cape Tormentine for the dock to be used as breakwaters for the ferry dock. There's lots of scavenging going on during this period too. And one of the things I'd heard when I was in Cumberland County working as a planner, I went to some of the old homes and people proudly pointed out what they called Ketchum chimneys, which were their brick chimneys outside the house. And the bricks had come from the ship railway project. So it lives on in different ways. So we have this failure of the Chignecto ship railway. And failure had global ramifications, as this was the only ship railway being built at the time. Others were being proposed, but this was the one that was underway. And a lot of visitors came to inspect the project, inspect the work, see how things were developing so that they could bring that information back for their own proposals that they were looking at. And I'll speak to some of those in a minute. For example, the Monterey Times reported It is not too much to say that the commerce of the world is interested in this project. Sir Benjamin Baker also spoke, and he said, there is good reason to hope that the much debated question of ships' railways versus canals will soon receive a practical answer with the opening of the Nova Scotia undertaking. So the eyes of the world were on Chignecto. Another example, Sir Benjamin Baker in 1891 wrote that the Eads, remember James B. Eads from last month, the bridge over the Mississippi River, the Eads proposal is still alive. It's only waiting the experience of the Chignecto Railway to be actively prosecuted. Oh, so we have this American connection to the Chignecto Railway. And I just showed you an image of what Eads was proposing. In 1879, James Eads wrote, like Ketchum before him, he wrote to the New York Tribune a series of letters proposing a 140-mile, 6-track railway, so that ships would be going in 2 different directions at the same time, across Mexico's Isthmus of Tehuantepec. This is the land near Central America, which is the isthmus there. It's quite a bit longer, obviously, than the Chignecto one. And he designed it to carry 10,000 deadweight ton vessels in both directions. And Elmer Corthell, his associate engineer on the Eads Bridge over the Mississippi that we heard of last month, Elmer Corthell is also the chief engineer working on this proposed railway across the Mexico's isthmus. So we see a relationship between the two, and Corthell is supporting the Chignecto project because they're looking at this project as well. And you can see the size of the vessel that they're proposing to take across. There's a unique aspect to the Eads proposal because he could not build a straight 140-foot rail line. So there were times the ship had to go around a curve. Well, the ship doesn't go around a curve. So he proposed to build turntables, and the turntables were put into a circular basin, and in the turntable, longer than the ship in diameter, the turntable sat on the bottom and the cradle went onto the turntable. Water was then pumped into the basin. The cradle and the ship floated up, and on the turntable floated up, turned, water dropped off, and off it went in a different direction. So they had a series of these turntables designed to bring the ship across the isthmus. Rather unique. I'll come back to Eads in a minute. Still talking about the impact of failure. The eyes of the world were on Chignecto Ship Railway. Unfortunately, the commerce of the world never did receive a clear answer to the ship railway versus canals. And people were saying, even James Eads first said, we should build a ship railway across the Panama rather than a canal. And the French engineers there said, well, no, it's a canal or nothing. And eventually, as you know, we did get a canal. It was never answered that a ship railway is better than a canal. The ship railway had caught the attention of the marine world. As Corthell pointed out, the hopes of all advocates of the ship railway method are centered in this comparatively small railway in Chignecto. So it was a pilot project, if you wish, for the world. The failure of the ship railway ended further prospects for ship railways, including one in Canada from Georgian Bay to Toronto. They too had visited the site and talked about the importance of this, and I think Elmer Corthell was a consultant on that particular project. In 1896, at the age of 57, Ketchum died in Amherst. And the local folks say he died of a broken heart because his project just wasn't going to be fulfilled. So in conclusion, the failure of the ship railway wasn't from infeasible technology or poor management. The maritime historian has pointed out for financial, political, and financially economic reasons it failed. While no one of these considerations would have been enough to defeat the project alone, together they made certain its collapse. But I think bad timing was also a major contributor to the ship railway's failure. Think back to the Great St. John Fire of 1877, destroying all of Ketchum's work. If we hadn't had the fire, he would have been proposing the ship railway 3 or 4 years earlier, and the railway would have been built before we had the global depression of the 1890s. It was just bad timing. Everything seemed to work against them. So in an epilogue, let me bring up a few points. That's what happened subsequent. I want to talk about the Tehuantepec Ship Railway, mainly because it ties in James Eade to the Chignecto project. He died at the age of 67 in 1887. He had been trying to get US government support for the project. He wanted the government to guarantee the dividends on the private investments on the railway. He had already received about a third of the money for construction from the Mexican government. They were quite happy. They gave him money. They gave him lots of land. They said, go to it. But the US government looked at it. There was a favorable report that had gone to the Senate, and the Senate adopted it, not unanimously, but a very large majority in favor of funding the ship railway. It was going into the House in 1887. It was slated to be considered by the House, and Eads died, and that sort of took the wind out of their sails, if I can use that pun. And things sort of lingered. Elmer Corthell continued to seek US government support. And the government support was guaranteeing the dividends, as I said, in exchange for special treatment for US ships crossing the isthmus on the railway. I think it was American ships would only pay half the toll that other ships would pay in exchange for this guarantee. He continued to seek US government support, but the ship railway was never built. However, the railway, the right-of-way had all been laid out. The Mexican government had put lots of money into this, and in fact, they continued to build sections of the railway, not as a ship railway, but just as a railway. There were some problems with that, but eventually they contracted with Pearson and Son of London, who we heard of in the Chignecto project, and they completed the railway in 1907 across the isthmus as the National Railway of Tehuantepec. And it transported cargo from ships. Instead of, they can't get across the Isthmus of Panama, so they came to the port at one end of the Tehuantepec, unloaded cargo, shipped it by rail across, picked it up on the Pacific side, and carried on and back and forth. So it did that very successfully, carrying a lot of cargo across the isthmus until the new canal was opened in 1914. But the railway continued, even without that demand, continued carrying domestic cargo and passenger service until 1953. So the remnants continued. Now, the interesting part, and this is only a sidebar, in 2020, the Mexican government began a $2.8 billion interoceanic corridor in the same location along the same railway to revive the National Tehuantepec Railway for container transshipment, as well as to develop an industrial corridor with a variety of industrial hubs, as you see on the map here, for economic development to this relatively poor region of Mexico, as well as upgrading the port terminals to handle 1.4 million 20-foot equivalent containers. It's our standard measurement in the container business by 2033. So this project is continuing to be underway. So there's a remnant of a ship railway, at least in a normal situation. Finally, in terms of an epilogue, in his will, Ketchum endowed the Ketchum Silver Medal to the University of New Brunswick. And this silver medal is awarded annually to the top civil engineering graduate at the university. And every 5 years, the Ketchum Medal winners alumni get together to celebrate. And this paper's been presented to them on several occasions in terms of who Ketchum was and why is the medal being provided to them and what's the significance of the medal. And so that continues on to this day. And when I look at I remember when I presented to the alumni at one point, I was quite pleased to see how many of them I knew. Either they were professors at the university or important engineers in the New Brunswick context. I mentioned that I sought to get the ship railway designated as a National Historic Civil Engineering Site for the 1989 conference. And my research on the ship railway and verifying that it was technically sound convinced the committee that yes, we could do that. And so in 1989, CSCE designated the Chignecto Marine Transport Railway as a National Historic Site. I'm very pleased with that. In 2012, the Nova Scotia government acquired the Chignecto Ship Railway lands for a hiking biking trail. The lands had initially been given to the Ship Railway Company for free by the Cumberland County, which is the county in which this is located in Nova Scotia. So the railway lands were given to them. Somehow or other, they ended up in the Casey family. And Bill Casey became, and I knew him when I was in Amherst a bit, but he eventually became member of parliament for many years, representing North Nova Scotia. And it was in his family, and he and his family sold the land at much less than market value to the Nova Scotia government to make it into a park, if you wish, or a hiking, biking trail. There is talk in Amherst, there's a group of people that are trying to develop a model of the cradle, the rails, a ship on the cradle, and a locomotive as a tourist attraction. Because you can see at the bottom here, this is the main Trans-Canada Highway between New Brunswick and Nova Scotia, and they're trying to attract tourists to remain in the Amherst area. One of the features of the Chignecto Ship Railway was it had to cross one major river, not that the Chignecto River is such a large river, but in order to cross it, they built an arch bridge across the river. And so this is the sandstone bridge being built over the Chignecto River. That was then, and today it's referred to as the Keystone Bridge, is now part of the provincial Chignecto Ship Railway Trail. And I've gone over that trail. When I went over it with a group of local residents, because we were trying to develop a trail back in the 70s, which we did successfully, only on part, but over the bridge here. And I saw a railway bogie just lying over on the side. It had been abandoned for 100 years, just sitting there. It was interesting. At the Tidnish end, the provincial government earlier had designated the site as the Tidnish Dock Provincial Park, and you can see the setting for the CSCE National Historic Site Monument. This block of sandstone was actually donated to CSCE, as well as the plaque, by Bill Casey. And he had moved the stone from another site on the railway, had it smoothed off and shaped like this, put a slope on it so that the plaque would rest on it. So we were very pleased with Bill's contribution. Looking at the site today, this is at the Bay of Fundy end, and you can see how the wet basin, the wetlock basin, has been totally filled in with silt from Bay of Fundy. But you can see the graving dock part or the dry dock part. This is the foundation of the pump house that we saw earlier. These are remnants left of blocks and stone that were going to be put in the railway or used later on in parts of the construction of the wetlock. These hydraulic pump house foundation blocks are still in place. There are lots of artifacts lying on the site. As part of my proposal to designate this, some members of the National History Committee actually came down to Amherst, and I took them on a walk one cool, dewy morning, and we, lots of us walking around with boots, wandering around this area, looking at what's available, and we were fairly impressed with what's left. At the other end, in the Tidnish area, you can see the ship railway, the alignment, and you can see the wetlock and the molds under the water that are still there, visible from above. So I have 2 pages of sources that you can look at your leisure. A lot of information available about the Chignecto Ship Railway and other ship railways, including the Tehuantepec Railway.
So how long do you think this canal or this railway would have remained viable if it had actually been built?
The question is, a hypothetical one, of course. But it seems, some people have looked at that and felt that it would be useful for coastal shipping into the 1930s. And so it would have had about a 50-year life, or 30 to 35-year life, or 40-year life as a viable economic function. However, if the ship railway had been built, the question arises, would we continue to use it for recreational and smaller vessels across the isthmus? Much like we do for a lot of the canals that were built in the 19th century, which are now, whether you're talking about the Erie Canal or the Rideau Canal in Canada, they're being used for recreational vessels, and they're still a historic artifact. So it might have continued to be used.
Interesting. And what do you think would have been its legacy? Do you think some of these other facilities might have been built, or would it have been the only one? Or
That's really a good question. The Eads proposal for Tehuantepec, I mean, it was being built by the Mexicans. They were looking for the Americans to come forward so the investors would come forward. And the federal government in the US, I mean, it was going into the House of Representatives. And as long as Eads was behind it, and from last month, he was considered to be one of the preeminent engineers in the United States. As long as he was involved with it, people were prepared to support it. His death really pulled the plug on the Tehuantepec. But had Chignecto been completed and operating, Elmer Korthel would have had more levers, if you wish, dealing with the House of Representatives to get the project underway in Mexico. So yes, I think things would have happened had this pilot project been successful.
what lessons should we take away from this?
Some of the lessons are that as engineers, and you're in the construction business too, we have to be careful and be aware of the political situation we find ourselves and the broader financial aspects of project construction. We can't just focus on the technical details. All projects have a political life, and we have to be aware of it. And obviously, there's a failure in Ketchum and the CMTR in not being able to deal politically with the concerns that were being raised.
So what about the Panama Canal location? Was it really ever considered as an alternative in that location?
Yes. James Eads' first proposal, and he started getting involved in ship railways after he completed the Eads Bridge in St. Louis. And so he began thinking about building ship railways. And he looked at the Panama first. And he really was proposing, because the French had a concession to build the canal, as you may recall. Eventually, the Americans took it on. But at this point, the French have got the concession, and he met with the French engineers and proposed a ship railway rather than a canal. But they weren't interested. They said, canal or nothing. So the next stage was, he says, well, if you don't want to build a ship railway here where it makes sense, we'll now move it up to the next stage. And so he moved to the Isthmus of Tehuantepec. There's a little corollary to that in the sense that Eads' work is all tended to be in the Mississippi Valley. And if you look at the geography of the Tehuantepec Isthmus, it's very close to the outlet of the Mississippi. And so there was a lot of support coming for the project from the Mississippi Valley into Washington to get this connection across the isthmus and allow American wheat and grain and all these other commodities to be shipped overseas over the Pacific easily. So there was a reason for the Tehuantepec as a second choice.
Well, this has been really, really fascinating. I put a new item on my bucket list for a place to go hike, and just looking forward to hopefully getting up there someday and walking from one end to the other.
Wow, there'd be a hike.
Yeah. I want a second bridge, originally built in Britain and then transferred to Arizona. And that sounds like another interesting aspect. And thank you, everyone. Thank you, everyone, for attending.
Thank you, and thank all of you for being here. Thank you all very much.
We'll see you all in May.
The new transatlantic cable webinars are coordinated by a tripartite ad hoc committee that includes the individuals listed here.